Hi, my name's John. Welcome to a video review of a new Artec 181 inverter MIG welder. Artec contacted me 2 or 3 weeks ago and said they'd brought out a new improved MIG180 called the MIG181. Would I like to have a look at the one? Absolutely, I'd like to have a look at the one. I've got a MIG180 at home, I've got one at work. I know lots of people that have got them, use them, and the 180 is a good, reliable, solid inverter MIG set. The new 181 is the same physical size, it's about the same weight, so it is nice and portable. The massive change is in the front panel. In the front screen, it's now got a digital display. It's got a lot of preset settings in for welding different thicknesses of steel. You basically punch in the thickness of steel you're going to weld, the wire size you're going to use, it works it out, and it gives you a setting that is very, very near. You can also tweak it in to make it just the way you want it to weld. That's enough talking. What I'm going to do now is plug it in, put some gas onto it, and we'll give it a try and see what it welds like. This is the new Artec MIG181. It looks very similar to a MIG180. Look inside. It takes 5 kilogram spools of wire. That's got 0.6 wire on at the minute. It uses 0.6 and 0.8. You can also put flux core wire into it. On the back of the set, you've got a normal gas connection, on-off switch, power cable, and a cooling fan. We're coming on to the front. This is where it all changes. We've got a digital display screen. We've got the standard Euro torch connector. That's the earth lead. That's a positive lead that you use during stick welding, and that's a connection for a spool gun. That's a flip up plastic screen which keeps dirt and sparks out of there. I'm going to power the welder up. There'll be a little bit of fan noise because fans run all the time on MIG welders. This is the new digital display, nice and bright, clear, it's easy to see. These are mode settings down here on the left hand side. The first one's a gas setting, that's 5% CO2 argon mix. The second one's 20%, that's an industrial mix. Then we've got flux core, then we've got MMA welding, which is stick welding. We're going to start off doing MIG welding, but I will be showing flux core and stick in a later video. Okay, these are the wire thicknesses, 0.6 and 0.8. The one that's flashing is a wire that was being used, so we're on 0.6 wire. On this side it shows you what thicknesses of metal it'll weld on 0.6 wire. It goes from 0.8, 1, 1.2, 1.5 up to 2 mil. On the left hand side shows you the wire speed in meters per minute. The right hand side shows voltage. We're going to start off with some 0.8 plate. So we'll go back to the beginning. So it's 0.6 wire, 0.8 plate. You have got a fine adjustment on the wire speed. You've got a meter each way. Same with the voltage. You can tweak the voltage a volt each way just to finally dial it in. So we're on 0.8 wire, 5% argon gas, and we're going to weld some 0.8 steel. I'm going to try and get some arc shots welding the various thicknesses of steel, not to show you how to weld, just to show you what the welder's capable of doing. This is 0.8 plate, a lap weld with a machine on its factory settings. That setting's pretty good. I wouldn't adjust that, I'll just use it the way it is. You hear the noise it's making the noise the MIG welder makes when it's happy. You can see all the welds penetrated all the way through. I'm going to weld the other side of the same joint. I'm going to try welding a little bit quicker this time. I've increased the travel speed and it seems to be putting down a nice flat bead. Absolutely nothing the matter with that. This is a fillet weld on exactly the same material. This is a very common weld in car body repair. Once again, 0.8mm plate, and we've got a 5mm hole drilled through the top plate. It's what they call a rosette or a plug weld. It's very similar to a spot weld. And basically all you do is touch the wire in the centre of the hole, pull the trigger and work around, and it forms a really strong plug weld. Right, that's gone all the way through, completely fused together, and obviously we'll grind the top off flat. When I've got the camera set up, I'm just going to run another lap weld along there. I'm going to move up from the 0.8 plate to 1.2mm and do the same welds. That's 1.2, so it's on 1.2mm, still on the 0.6 wire, and we're on the 5% argon CO2 mix. This is a lap joint on 1.5mm on easy set basic settings. Basically there's nothing much the matter with that, it's going in very nicely indeed. That's a good weld. It's gone all the way through. I'm going to weld the other side of the same joint, but I'm going to try and get the travel speed a little bit quicker so I can get a flatter bead. Faster travel speed, definitely producing a flatter bead. I'm really impressed with this for a second, straight out of the box with no adjustment. This is a fillet weld on an inside corner joint on exactly the same settings. Right, for a straight out of the box weld, that's not bad. These are the plug welds in 1.2. Right through, 100% penetration, nothing at all the matter with that. I'll run a fillet weld up there because I've got the camera ready to go. I'm going to turn things up now and go from the 1.2 up to 2mm. 2mm is about as thick as you can weld on 0.6 wire. So we're on 0.6 wire on normal MIG gas, and we've got it set for 2mm plate. I'm going to do the same 3 welds and see what sort of results this gives. This is the lap weld on 2mm plate on easy set. I'm just going to turn the power up 1 volt. Not have here quite a considerable difference. I'm going to weld the other side, and I've turned the wire speed down 1 and left the voltage up 1. Very happy with that. This is a fillet weld and 2mm plate. Right, there's very little wrong with that. A little bit there's me moving around trying to weld around the camera, but basically that's a good weld. This is the plug weld on 2mm. This time the hole got 8mm. Okay, so that was 2mm on 0.6 wire, and I turned the wire down 1 and I turned the volts up 1, and I found that gave a better weld. I'm going to turn things up again and go straight up to 0.8 wire. In easy set, it's already flashing 0.8 wire, and that's material I can weld with the preset settings using 0.8 wire all the way up to 4mm. I've got some 3mm plates, so we'll start with the 3mm plate. Right, so it's flashing 3mm, it's flashing 0.8, and I'm on the correct gas. So basically, it's as simple as that. That's ready to start welding. As previously mentioned, you can tweak your wire speed and your voltage up or down just to fine tune the weld. This is 3mm plate on the easy weld base setting. That's quite a decent weld for a base setting. I'm going to turn the wire feed down a little bit because the weld is still a little bit crowned, and then see how that goes. 3mm is the sort of stuff a lot of our chassis is made out of. Quite decent material. Once again 3mm with the wire feed turned down 1. Right, that is a really good weld. It's penetrated well, you can see it burning in. Very happy with that. This is the fillet weld, 3mm plate, exactly the same settings. Nothing much the matter with that really, is there? Right, I've let it cool down. I've put the settings back to factory standard. That really is biting in, it's making the right noises. Once again, I'm very happy with the weld. I'm going to move up onto 4mm plate. So it's 4mm plate, 0.8 wire, normal, MIG gas. This weld is 4mm plate on easy weld on the factory settings. That is quite an impressive weld. Once again, it's a little bit crowned, so what I'm going to do is turn the voltage up 1 volt, let it cool off, I'll turn it over and weld the other side, but that really is biting in deep. This is the 4mm plate with 1 volt added. That's made a massive difference, that really is going in now, that. That is a proper weld. This is an outside corner joint in 4mm easy weld. Not a great lot the matter with that neither. This is an inside corner joint. Once again, 4mm wire and standard easy weld settings. That is a beautiful weld. It's bordering on spray transfer. That is a really, really nice weld. I've gone through the basic steel settings that are built into the machine and they work very well. But what if you want an ordinary MIG welder? You don't want to be told what you can and what you can't weld. Dead simple, turn up easy set and you've got a MIG welder. You've got wire speed there from 1.5 meters a minute all the way up to 12. And you've got voltage from 13 all the way up to 23. That is a basic MIG machine. So you can set your wire speed whatever you want. You can set your voltage to whatever you want. And you can weld and you can play with it and dial it in to your heart's content. It's all well and good sitting at a bench welding nice clean metal. Unfortunately the world I live in isn't like that. I weld a lot of stuff like this. Exhaust repairs. This is a rusty exhaust. It's not completely rusty, but it's fairly rusty. So I'm going to try welding that. I'm going to put the machine on manual settings and set it up how I would set it to weld something like that. A good base setting for rusty exhaust is 6 meters a minute and 17 volts. That'll get you, it'll weld and then you can fine tune it from there. I'm not going to take the rust off. Normally I would try and grind it, but you can't always get in. I'm going to try and weld straight into the rust. As I would say, real world welding. That's not too bad. The secret is trying not to blow a hole in it. Right, so this really is thin material. There's probably 1.5 million of metal left in there. And if we had to repair that, suppose it was a crack or a split, we can make a little patch like that, tack it on and weld round it, and that's exactly what I want to do. I'm going to simulate repairing a piece of rusty old exhaust, sort of a real world repair. And we'll tack the patch on, and then we can have a little bit play around with it, manipulate it, see what we can do with it. Once you get a little bit of weld onto it, you can sort of manoeuvre it and play with it and get it how you want it. See, it's not one to arc onto the rust. Right, so we've got the patch fastened on so it won't fall off. That's actually a piece of stainless steel, it just happened to be lying on the bench. Right, so I'm going to put the weld screen on now, and we'll see if we can get this welded together. You do it in little tacks so you don't burn a hole through it. That really is paper thin. But it's welding, it's not just sticking on top. Sometimes you can actually get a better weld by pulling the weld instead of pushing. It's not the prettiest repair in the world, but it isn't going to fall off. I must admit, I was sceptical at first because I don't like change digital things, sort of. I like nuts and bolts and spanners and knobs, but basically the settings on this welder are easy to use. It's very, very simple to navigate. It's called Easy Set, and it is easy to set. It's going to be ideal for the novice welder who's going to weld something he doesn't know where to start. You can dial in on here and get very, very near, straight out of the box, and produce some really good welds. So I think the improvements that they've made are a massive improvement in as much as it helps you get the best from an already very good machine. I hope you enjoyed that video as much as I enjoyed making it. Anyway, thanks for watching.